So let's get started. We're going to do the left to right direction first. This is an if and only if, so we have to go if this, then this, and then later we're going to go if this, then this. But we're going to start with if A, B is even, then either A or B is even. So let's get started. So if you were just writing blindly, you would start with the following. Let A and B be integers, and such that AB is even. Okay, now where do we go from here? Nowhere. We could have probably guessed that AB being even is not going to be a really helpful hypothesis because it's a derived quantity. It doesn't give us information about A or B specifically, just sort of some conglomerate information. And though we know that this theorem is true because you've known it for a long time, in terms of actually proving it, this condition is just not helpful. So we're going to want to do the contrapositive. We flip it around. It gives us information about A and B directly instead of about AB, which is a derived and therefore less helpful commodity. So let's rewrite this as a contrapositive. Put a little note here, indicate that we're doing it by contrapositive. And then so what we want to show is that for all A and B in Z, if not this, and remember not A or B means not A and not B, so A not in even becomes A odd, and B odd implies not this, which means AB is also odd. And now this becomes a really direct and simple thing to show. Knowing that A is odd and B is odd, we can start writing definitions. So then there are integers, let's call them M and N, where A is equal to 2M plus 1 and B is equal to 2N plus 1. So the derived quantity, we can sort of write it out and simplify, and that's clearly odd. So AB is odd, as desired. Okay. So once you flip this thing around, once you figure out what you're actually doing, you figure out that this hypothesis is not helpful, so you flip it around by the contrapositive, get going, correctly negate this or this turns into not this, and not this implies not this, right? That's our contrapositive. So when we get into it, since A is odd and B is odd, and I guess I should have written let A and B be odd. I should have written that at the beginning. That's a little bit embarrassing. So assuming A and B are odd, then there are M and N and Z. No significance to these letters. That's just something you can do. And you just write out your definition. A is 2n plus 1, B is 2n plus 1. And then algebra just takes care of the rest, and you get what you were going for. So the proof is simple once you figure out what you need to show and figure out how you need to rearrange it. Okay, and that's going to be a good technique for the next couple weeks. Okay, and next time I'll do the other direction.